Today we're going to be talking about vectors, specifically relating to linear motion. Okay, so vectors and scalars, very similar concepts, but they often get confused. So scalar has only magnitude, and vectors have magnitude and direction. Okay, so that's the key difference between them. Vectors have direction. Some common examples of scalars that you'll find relating to linear motion is speed. So speed is a typical scalar because with speed, we don't necessarily need a direction to know what speed is. But if we look at something like velocity, velocity is what we call a vector, just because with velocity, you need to have that direction as well when we're talking about velocity. So velocity can either be positive or negative, depending on whether you're talking about the horizontal or vertical plane. But with speed, don't need to say whether it's positive or negative, it's just the speed. So it doesn't necessarily have that direction component associated with it. All right, so if we have a look at this diagram here, we can see there's two vectors, vector A and vector B. Now, another thing you have to do with vectors is know how to add and subtract vectors to find the resultant vector. So if we look at this one, we have two vectors, vector A, vector B. Now to add these two vectors up, we can draw a line, which is what I've done here, and there's a red line here. That represents the resultant vector. Now to figure out what this resultant vector is equivalent to, we need to follow these vectors here. So we're going to follow them from this point, we go all the way through here, and then we go to the point of vector A, and we go back up to the point of vector B. So if we trace from here all the way around to here, we have A moving in this direction, the positive direction, plus vector B moving up in that positive direction as well. So that means that this vector here is going to be equal to vector A plus vector B. All right, so now if we look at this other diagram on the right here, we have vector A and vector B, but it looks a little bit different to the one on the left because these arrows are in different directions. So now we're still going to do the resultant vector. So we're going to connect the two heads of the vector. Jesus, this is fucking drawing. So I'm going to connect the two heads of these vectors here. All right, just like that. But now the direction is important because with vectors, you need to consider direction and the magnitude. So for this one, we're still going to start here and we're going to trace all the way around back to here. For this first one, we're going in the opposite direction as the arrow of the vector. So we're going down and this vector is going that way. But I have to go from A to B because we need to go from the tail of the resultant vector to the head of the resultant vector. So we need to go that way, which means we have to go down A, which means A is going to have that negative value. And we have to go across to B. B has that positive value because we're going from the tail to the head, and I have a positive value. But A is negative. So it means we've got negative A, negative vector A, plus positive vector B. That will give us the resultant vector. Let's just call it vector C. Another way of writing this is B vector minus vector A will give us vector C. All right.